Hello everyone, once again welcome to Mathline channel. In this channel you will be getting a basic maths lesson every week. Those who have not watched the previous lessons, please watch from the beginning and continue watching. Also share and forward as much as possible to the students of all standard. So we will start today's lesson with a new topic, that is inscribed anchor and intercepted arc. In this, I would like to explain what is the meaning of inscribed anchor and intercepted arc, also the relation between them. So see the figures. In the first figure, you can see an angle and a circle. The angle is formed at a point P by the endpoint of an arc AXB. Clear that? Or it can be said that an angle is formed or subtended. For formed, you can say the word subtended. An angle is subtended by the endpoint of an arc AXB at a point P in the interior of the circle. That is the first figure. And the second figure, an angle is subtended by the endpoint of the arc AXB at a point P in the exterior of the circle. In the third figure, an angle is subtended by the endpoint of the arc AXB at a point P of the circle. The point P is on the circle. Here the angle is subtended by the endpoint of the arc AXB at a point on the circle. So in these three figures, in the first and second figure, the angle APB is not an inscribed angle. In the third figure, angle APB is inscribed in the arc APB, the major arc. So what is the condition for an angle is said to be inscribed? The vertex should be on the circle, or vertex should be on the arc in which it is inscribed. Remember, angle APB is inscribed in the major arc, not AXB. Don't confuse. You cannot say angle is inscribed by this arc AXB. Not that. Angle is inscribed in the arc AXB. Clear? Angle is inscribed in the arc APB, not AXB. In the major arc. So what is the condition? The vertex should be on the major arc in which it is inscribed. And what is the arc AXB is called? Arc AXB is called intercepted arc. That lies in the interior of the angle. And also the endpoints are on the side of the angle. Clear? Also, AXB is the minor arc and the corresponding major arc is APB. In that it is inscribed. Don't confuse. Clear? So, what is inscribed angle? If the vertex of the angle is on the arc in which it is inscribed and the endpoint of the arc are on the side of the angle. These are the two conditions to be satisfied for the inscribed angle. So understood these two figures. In these two figures, APB is not an inscribed angle. In the third figure, it is an inscribed angle. Which is inscribed angle? APB is inscribed in the arc APB, and AXB is the corresponding intercepted arc. Clear? Now there is a relation between the inscribed measure of the inscribed angle and the corresponding intercepted arc. What is that relation? Measure of an inscribed angle is equal to half the measure of the corresponding intercepted arc. How to get the measure of AXB? Arc AXB, by the definition of measure of an arc, it is the measure of the angle formed at the center of the circle, that is AOB. So according to that, measure of angle APB equal to half the measure of angle AOB. That is nothing but measure of arc AXB. What is the relation? Measure of an inscribed angle is half the measure of intercepted arc. The measure of intercepted arc is measure of angle AOB. Now one more property is, see this figure. This also, here you can see two angles are inscribed in the same arc. Which is the arc? In which arc it is inscribed? Arc BAC, or you can name it as BDC. Which is the corresponding intercepted arc? BAC. So by the property of relation between inscribed angle and intercepted arc, measure of angle BAC equal to half the measure of arc BXC. Similarly, measure of angle BDC equal to half the measure of arc BXC. So from 1 and 2, what you will get? Measure of angle BAC equal to measure of angle BDC. So what are BAC and BDC? Inscribed angle. In which? In the same arc. Which arc? Arc BAC or arc BDC. Same arc. So what is this relation? What is the property of relation? Angles inscribed in the same arc are congruent. If you take one more point and join, you will get another inscribed angle. That measure also equal to BAC or BDC. In this way, you take any number of angles, inscribed angles in the same arc. You will get it is equal to half the measure of arc BXC. The corresponding intercepted arc is same for all the inscribed angles in the same arc. Clear? So, what is the relation? Measure of an inscribed angle is half the measure of the corresponding intercepted arc. And angles inscribed in the same arc are congruent. Clear? That is obtained from this relation only. If you take any inscribed angles in the same arc, their measures will be half the measure of the corresponding intercepted arc, because the corresponding intercepted arc will be same for all those inscribed angles in the same arc. So, understood? There is any confusion between intercepted arc and inscribed angle? Remember, angle APB is inscribed in arc APB. Clear? And AXB is the corresponding intercepted arc. And measure of AXB is measure of AOB, measure of the angle formed at the center or subtended at the center. What is the meaning of subtended angle? The angle formed at a particular point. Angle subtended at the center, or APB can say angle subtended at a point P of the circle. Understood what is meant by subtended? Formed at a point. So I think you understood about inscribed angle and the relation between inscribed angle and the corresponding intercepted arc. Also the property angles inscribed in the same arcs are congruent. More about inscribed angle you can learn later. This is the end of today's lesson. Thank you for watching this lesson. See you next week with a new topic. Have a nice day. Bye bye. See you.